Welcome to a presentation brought to you by the American Wood Council. Thank you for your participation in our webinar today. This webinar is intended to provide general information only and does not constitute professional or engineering advice. Please note that this webinar is being recorded, and by remaining a participant, you automatically consent to such recordings. If you do not consent to being recorded, please disconnect from the session. This presentation is worth 1.5 LU HSW with the AIA and 0.15 credits with the ICC. To receive credit for the course, you must attend this webinar for a minimum of 80 minutes. At the end of 80 minutes, you will see your certificate appear on your webinar console. Your certificate will also be uploaded into your learner profile on learn.awc.org, provided you registered for today's webinar with the same email address as your account profile. At the end of today's session, our presenter will have a live Q&A with the audience. Please input your questions into the Q&A panel throughout the session. And now, for today's presentation.
Greetings and welcome to IBC 2021 Code Conforming Wood Design based on the 2021 International Building Code. My name is Buddy Showalter. I'm a senior staff engineer with the International Code Council, and I'll be joined today by Ed Lazinski of the American Wood Council. Hopefully you've seen the description, and that's why you're here today. So I won't read from the slide or spend a lot of time here on this course description. You'll have that available, hopefully with the handouts that go along with this webinar. But I will spend a little bit of time talking briefly about the learning objectives for today. And these are sort of the four main topics that we're going to be discussing here today. With the structural elements, we'll be looking at identifying maximum building size and use parameters for wood as the primary structural element, and then identifying sources of structural provisions when using wood. We'll also talk a good bit about fire resistance and identify methods that the code establishes for determining fire resistance of wood assemblies and elements. We'll talk about some special provisions like sprinklers and compartmentalization, and then non-structural uses where we apply provisions such as those in the code for finishes and appendages. So those are some of our learning objectives for the day. The document that we will use as a curriculum, if you will, for this webinar today is called the 2021 Code Conforming Wood Design and the IBC. These bullet points here on the screen give you a sense of the major items covered in the Code Conforming Wood Design, and this will also serve as somewhat of an outline for this presentation today. We'll be covering each of these topics as we go through the presentation today. So we'll start with use and occupancy classification and continue through those other items. There are effectively 10 occupancy classifications in the building code based on building hazards, and the Code Conforming Wood Design focuses in specifically on 8 of those. You see the list here: assembly, business, educational, factory or industrial, institutional, mercantile, residential, and storage. And while wood is used in the occupancy classification U and H, since Group U is really for agricultural and less hazardous occupancies, and since Group H is used for much higher hazard occupancies, those are not within the scope of the Code Conforming Wood Design. So we'll be covering the 8 occupancy classifications that you see listed here, and those are the 8 that are also covered in the document known as Code Conforming Wood Design. So within the building code, and you'll see this within the document as well, Chapter 35 is a very comprehensive listing of all referenced codes and standards. So rather than trying to put effective dates of standards throughout the text of the IBC, you'll simply see a reference to a particular standard. And then Chapter 35 will provide that reference standard along with the standards development organization, identification, the complete identification and title of the standard, and an effective date. And so that's a really important part of the IBC so that you know which edition of the reference standard is current. And the example here on the screen is the AWC National Design Specification for Wood Construction, also known as the NDS. And so the specific reference in the 2021 IBC is to the 2018 NDS. And we'll see some of the other key reference standards in the code today, especially as we talk through the Chapter 23 provisions of the code. One of those is the 2021 Special Design Provisions for Wind and Seismic. Another is the 2018 Wood Frame Construction Manual for 1 and 2 family dwellings. And we'll get into a little more detail on all of those as we work our way through the program today. So our next topic is going to be types of construction. And prior to diving into this topic, I think it's important for us to distinguish between a couple of code-defined terms in the IBC. One is non-combustible, the other is fire resistant. So fire resistance is defined very specifically in 703.2 of the code. Non-combustible is defined in 703.3 of the code. And when we start talking about different materials used in construction, and in this case today we're talking about wood, these terms are not synonymous. They're not to be used interchangeably. They're different concepts. For example, steel and concrete are classified as non-combustible materials. Yet there are provisions in the code that require additional fire resistance to be added or designed even for those non-combustible elements. On the other hand, wood is classified as a combustible material, yet it has some inherent fire resistance, and we'll talk a little bit more specifically today about that inherent fire resistance and how we can supplement that with additional non-combustible materials to increase the fire resistance of wood materials used in construction. So Chapter 6 of the IBC defines various construction types. There are 5 different construction types listed in Roman numerals 1, 2, 3, 4, 5, and then some subcategories within each of those construction types. Even in types 1 and 2, which are primarily considered to be built of non-combustible products, there are specific applications permitting the use of wood in types 1 and 2 construction. And so we'll look at those as we go through the program in a little more detail today as well. So type 5 construction permits the use of wood or any other approved material in load-bearing and non-load-bearing structural elements. So this type 5 construction typically ends up being your smaller height and area buildings. And so wood is obviously permitted in types 5A and 5B construction. We're kind of working our way backwards here in the construction types. Type 4 construction, and specifically type 4-HT is characteristic of what is known as heavy timber construction. So prior to the 2021 codes, heavy timber was all type 4 construction. And now in the 2021 code, as we'll see in the next slide, we've got 3 new classifications of type 4 construction. So type 4HT is our legacy heavy timber construction type, where the exterior walls are of non-combustible material or fire retardant treated wood or protected cross-laminated timber, or CLT, which is a relatively new wood product that's being used in mass timber construction. Then in type 4HT, the interior building elements can be made of solid or laminated wood. So this is, again, our traditional, or if you want to call it legacy, heavy timber type of construction, still permitted in the code. Similar heights and areas as we've always had for this type of construction. But new to the 2021 code are 3 new construction types. These 3 new construction types, 4A, 4B, and 4C, require that all building elements be constructed of either mass timber, meeting minimum size requirements from Chapter 23, or of non-combustible elements. And the photo here you see on the screen is a hybrid building built with concrete cores where the elevators and egress shafts are located, and then wood or mass timber wrapped around those concrete cores. And so mass timber or non-combustible construction are the only 2 types of materials that can be used in construction of 4A, 4B, and 4C. In other words, light frame, repetitive member, 2x4, 2x6 construction is not used in these types of applications. Only mass timber of a minimum size or non-combustible products. Then we get to type 3 construction. That's going to require either non-combustible or fire retardant treated wood in our exterior bearing walls, and those need a 2-hour minimum fire resistance rating. In type 3A, these subgroups 3A and 3B, in type 3A, you're going to see a requirement for 1-hour fire resistance ratings for building elements other than those non-load bearing walls. And type 3B, then we're not going to require any fire resistance rating other than the exterior bearing walls. And again, that first bullet there indicates that we need that 2-hour fire resistance rating in those exterior bearing walls. Types 1 and 2 construction, as I mentioned earlier, are going to be primarily of non-combustible structural load-bearing elements, but there are allowances in the code, specifically in Table 601, footnote C, where we can use or specify heavy timber or mass timber in the roof system for types 1B, 2A, and 2B, and that's as an alternative to the 1-hour fire resistance rated non-combustible roof elements. So wood can be used literally in all 5 types of construction, but the heights and areas will be limited, limited, I guess, is a good way to say that, for certain construction types, and we're going to look at that next and see how that applies to these wood products. So Chapter 5 of the IBC provides size thresholds, that meaning heights and areas, for all types of buildings. And specifically for wood frame structures, those limits, those height and area limits, were often determined based on structural limitations rather than code limitations. But now, with the advent of cross-laminated timber, which has significantly greater structural capacity and fire resistance characteristics, that's allowed the structural limitations for wood buildings to advance beyond what we've seen for our traditional conventionally framed or heavy timber buildings. And so we're going to explore that in this section here. And we'll start by looking at the 5 different construction types and just getting a sense of how those compare. And you'll also see us highlighting some of the new construction types, as I mentioned, 4A, 4B, and 4C. So this is from Table 504.3. These are allowable building heights in feet above grade. And this is an excerpt of the table from the code. We've sort of condensed down a lot of the information so it kind of fits easily here on the slide. Again, trying to show just a few of the specific use groups that we talked about earlier. But for ease of learning today and just ease of comparison, we're going to focus in on our building on our business occupancy classification B. So in all the examples that you're going to see here today, we're just going to focus in primarily on that business occupancy classification. And you see the other occupancy classifications that are grouped similarly. But also what you see there in the second column are the sprinkler qualifications or what we would use in various buildings in terms of sprinkler systems. So S is going to designate a full NFPA 13 automatic fire sprinkler system. NS would designate a non-sprinkler building. And then when we get into our residential occupancies, you'll see 13D and 13R. Those are different types of NFPA sprinkler systems, very specific to residential construction. And we won't get into a lot of detail on that today. Just know that those are going to show up in these tables as well. But for our business occupancy, a fully sprinklered building, we work our way across the table. We see that for a type 4C building, the maximum height in feet is 85 feet, which is identical to type 4C, which is type 4C is 85 feet, which is identical to type 4HT, which has been the height limit for heavy timber structures for literally decades. So 4C is a pretty similar type of construction to type 4HT. The difference being there's some additional fire protection features in type 4C that are going to allow some higher number of stories and a little bit larger area that we'll see in the next couple of slides coming up. And you can see heights in feet for types 4A and 4B as well as type 3 and 5 construction. And so this is a summary table for those allowable heights in feet. Then we get to table 504.4, and we've got allowable number of stories above grade. And similar to the previous example, if we look at a business occupancy fully sprinklered an NFPA 13 sprinkler system and we work our way across to type 4C, we notice that we can go up to 9 stories, which is more than we can do with type 4HT. Notice 4HT just to the right of that red box is allowance of 6 stories. So because of the additional fire protection features built into type 4C, we are allowed some additional stories, even though the height limit in feet is going to be the same as type 4HT. And so that does allow for some additional stories in these types of buildings. Then we get to table 506.2. This is our allowable area factor, A sub T. And it's a very specific term, allowable area factor, because this factor or number that we're going to get from the table ends up being used in equations that determine the maximum allowable building areas for the buildings that we're talking about. And so again, for an occupancy classification B, we're gonna look at 2 numbers here for an example we're going to do in a little bit. One is the non-sprinklered factor, and under type 4C, we see that's 45,000 square feet. So all these numbers in this table are in square feet. And then the SM value is for multi-story buildings, and that factor is 135,000 square feet. The S1 number that you see between those two is for a single story application. We're not going to be looking at that in our example. And then again, notice the residential applications where you could also have a 13R sprinkler system, and there are different area factors specific to those occupancy classifications. So just note these 2 numbers here. NS is 45,000. Our SM value is 135,000. That's going to show up in a couple of these equations that we're going to be looking at next. So the allowable building area for a single occupancy, 1-story building, is calculated per equation 5-1 of the code here in chapter 5. And so that A sub T factor is that tabular building area factor that we just looked at in the table. The NS is a non-sprinklered value. We're going to be calculating an allowable building area, A sub A, and we're introducing a new factor here, I sub F, which is the area factor increase due to frontage. And that's the amount of open perimeter around the building. And we'll talk specifically about that and how we determine that I sub F value here in a little bit. For multi-story buildings, single occupancy yet multi-story, we're adding another variable here, which is S sub A. And S sub A is the actual number of building stories above grade plane, but it is capped or set at a maximum value of 3. So the example we're going to look at is a 4-story building, but that S sub A value is going to be less than or equal to 3 for all multi-story buildings. Now, there's one exception you see here at the very bottom, the last bullet, that shows S sub A equal to 4 if we're talking about certain group R occupancies. But for our purposes today and in general, most calculations are going to set S sub A at a maximum of 3. So here's our example where we've got a 4-story building, and if you look down here in the bottom left, you see we're gonna look at a type 4C business occupancy, again being consistent with the example we're using today. It's a fully sprinklered building, so we're going to assume an NFPA 13 sprinkler system. So that SM value that we saw earlier in the table is 135,000 square feet. Now, we're going to assume for right now no frontage increase. So I sub F equals 1. We're not going to take a frontage increase, we're going to assume an open perimeter less than 20 feet on all four sides of the building. So that's just going to eliminate one variable for now to help us work through this example. Then we'll look at that frontage increase in the next slide. So that SM value is 135,000 square feet. We know that the S sub A value we talked about a little bit earlier is capped at 3. So to determine our maximum building area, we're going to multiply 135,000 times 3 to get our total building area of 405,000 square feet. That's the number we see up here in the top right of our screen. So each story may not exceed that 405,000 divided by 4. So we'll take the entire building area and divide by the total number of stories, which is 4. And that gives us a maximum story. Assuming each of the stories is the same area, then each story could be 101,250 square feet. So that's how we would determine our maximum building area and then maximum floor areas, assuming same occupancy throughout the building and equal story areas. If we have unequal story areas, let's say we had larger areas on bottom floors and the building neck down to smaller stories above, no single story could exceed that SM factor of 135,000 square feet. So that's our first example. Now we'll take the next step and look at this building set on a lot, and the distance, the frontage distance of that building to lot lines or other buildings is what is going to help us determine that area frontage increase, or I sub F factor. And there's a table for this on the next slide, but when we look at this building, which is 250 feet on one side by 500 feet on the other side, with the setbacks that you see around that building, you see that the smallest one down here at the bottom is 15 feet. And so in order to justify a frontage increase, you have to have at least 20 feet of distance to the closest lot line or another building. So this side of the building here, set at 15 feet, does not qualify. So the way it works then, we're going to take the 3 sides that do qualify and have a distance that exceeds 20 feet. And we're going to add up the length of those sides. So 500, 500, 250 gives us 1,250 feet. We're going to then divide that by the total building perimeter of 1,500 feet, and that gives us a 0.83% of the perimeter of the building that has that 20 feet or greater separation distance. Then we're going to use W of 28 feet, which is the smallest distance that is still greater than 20 feet, but less than 30 feet. And you'll see in the next table why we're going to select that value of W equals 28. And we're going to come up with a factor of 0.63 in this next table. So trying to set this up so you see the factors that we would use in this next table. So we're, as we calculated on the last slide, we've got 83% of the sides of this building which have that at least 20 feet of open perimeter or setback to the lot line. So we're going to be in this bottom row here between 75 and 100. We're going to work our way across to that W equals 28, and that number 28 feet ends up between 25 and 30. And so this simple table here gives us an I sub F of 0.63. Now, interpolation, there's a footnote on this table in the code that says interpolation is permitted, and Some of the tables that have been developed for the Code Conforming Wood Design document provide those interpolation values. The calculator that Ed is going to talk about here later on in the program also provides more exact values than what you can derive from a real simple table like this. So now let's go back and plug all this information into our example. So we've got a SM value of 135,000. We've got an NS value of 45,000. We plug that into our our second equation that we looked at earlier, which accounts for this frontage increase of 0.63 times NS. We end up with a total building area, now that we can account for the area increase for frontage, of 490,050 square feet. So for the total building of 4 stories, we divide that by 4. Now our allowable area per story goes up to 122,512 square feet. And that now gives us our allowable area per story. However, if we look at our actual dimensions of the building, 250 by 500, that says our actual square footage is 125,000, which exceeds our allowable. So that's no good. NG's no good. We're about 500 or 2,500 square feet short in this particular example. We are allowed to interpolate, but even if we go in and sharpen our pencil and interpolate, we still end up about 58 square feet short of our allowable. So at 124,942, we're still short. So what can we do? There are a couple options here. One, we could, if we're early on in a design site plan, if we are able to shift this building back into this lot just an extra 5 feet or so, that will get us the ability to count this front of the building that we couldn't count before because we were less than 20. So hopefully this part of the design and plan review is happening early in the process where you could make those types of adjustments. Another one would just be to shorten up one dimension of this building by about 6 inches, and that's going to get you pretty much what you need over those long side dimensions. So those are your options to be code compliant for these allowable area calculations. So we're going to then jump into Chapter 9 of the IBC, and that's dealing with sprinkler systems. For many occupancies, Chapter 5 is going to give us areas that are going to exceed what are permitted in Chapter 9 for our non-sprinklered buildings. And most of these thresholds in Chapter 9 apply to all construction types, not just wood. And so a really important consideration is whether or not your building is or contains sprinkler systems or not. And a lot of the tables we'll be looking at here as we go through the program are going to show you a pretty clear distinction between a sprinklered and a non-sprinklered building. In addition to larger areas, there are a lot of other trade-offs that come with adding sprinklers to a building. Yes, it will provide some additional cost, but a lot of these trade-offs may reduce costs in other areas. So it's worth exploring this option of sprinklers to see if you can get reductions in corridor ratings and opening protection, some flexibility in your means of egress, travel distances, number of exits, common path of travel, reductions in dwelling unit separations, alternates to emergency escape openings, alternates to fire and smoke damper requirements, interior finishes we'll talk about a little bit later, and others. And so sprinklers not only help you in your heights and areas, but some of these other items as well that may actually help in the in your process of uh, providing affordability to offset the sprinkler costs. Now we'll get in specifically into the code conforming wood design building area tables. And so for the just an intro to what these tables are going to look like and what you're going to see. We'll spend a little more time on this particular slide. This table only covers types 3, 4, and 5 construction. We talked earlier about types 1 and 2 being primarily non-combustible. So these tables are condensed down where we're just going to be looking at 3, 4, and 5. You'll see number of stories there in the first column. You'll see that percentage of frontage for these buildings grouped into groups of 25%, 0 to 25, 25 to 50, 50 to 75, 75 to 100. So that'll give you a sense of frontage increases that we looked at in our earlier calculations. And then we'll look at non-sprinklered versus sprinklered buildings. So this table gives you your Group B occupancy, non-sprinklered, and different maximum floor areas based on those calculations that we just went through. So this is a pretty convenient lookup table, especially during that exploration phase where you're looking to see just how large a building you can build. Then when we get to the footnotes, this is where, again, I'll spend a little time here and then move through it more quickly in later tables. But once we get above 4 stories above grade, then we're going to use that same equation that we used before. We're going to multiply by 3 to get our maximum building area. Then we're going to divide by number of stories to get the area per floor. So that all that math's already been done as we look at these tables. The frontage increase is going to assume an open space of 30 feet or more. So that's really focusing in on that last column of the table that we looked at earlier for that frontage increase. And that just keeps those calculations easier. And then we mentioned interpolations permitted. It's permitted in these tables as well. And then you'll see some other footnotes that in a lot of cases are specific to the use group or whether or not that building is sprinklered. So that first table 3 there is for a non-sprinklered group B. Then you'll see a table 4, which is for sprinkler buildings. And in this case, the areas increase pretty substantially for sprinkler buildings. And the number of stories, as you can see here, goes up, at least on this slide, up to 6 stories. But I'm going to jump to the next page because new to the 2021 IBC, types 4A, 4B, and 4C allow us to go even beyond those 6 stories that were allowed for type 4HT. So 4A construction goes all the way up to 18 stories. 4B goes up to 12 stories, and 4C goes up to 9 stories that we saw in some earlier slides. So we've tabulated these allowable maximum floor areas per story for all these new types of constructions here. So that's a sense of the table 4 footnotes, very similar for the first 3, for example, footnotes, and then you'll get a few footnotes very specific to Group B sprinklered building. Now, back to our example that we used earlier, we had a 4-story type 4C building, and because of these percentage frontage numbers here in the second column going in increments of 25%, it makes it a little bit tougher for us to compare apples to apples. But for this specific example, because we only have 2 sides of the building that exceed that 30-foot threshold that is in the table or in the footnotes that we're using for these tables, that kind of limits how we can come up with a number here. And so this number, 118,125, still less than that 125,000 that we looked at earlier. And substantially so, again, because of some of the simplifications we've had to do for these tables. So just know there's some conservatism, some simplification as you're using these tables that may give you, a starting point for your height and area analysis. And then, if you're not within or not quite where you need to be, you might need to sharpen your pencil and actually go use the equations, do some calculations, or use the calculator that Ed's going to show you here in just a little bit. So there are also provisions in the code for unlimited area buildings, and we'll just walk briefly through some provisions in section 507 of the code for groups B, F, M, and S, 1-story buildings with NFPA 13 sprinklers and 60 feet of open perimeter around the entire building. We could have an unlimited area building. So we go to even a group E occupancy, 1-story, fully sprinklered, as long as the classrooms have 2 means of egress, one to the outside, and we've got that 60 feet of open perimeter, we could have an unlimited area education building and type 3A or 4 construction. So we're focusing in on different types of wood construction here that could be used for these groups. Here's an interesting one. This is group F2 or S2, 1-story, but non-sprinklered. So as long as you've got at least 60 feet of open perimeter, the F2 and S2 buildings have lower hazard combustibles or non-combustibles, that would be used in these particular groups. And so even a non-sprinkler building within these parameters could be unlimited area. And then here's the difference in this slide is a 2-story B, F, M, or S, fully sprinklered, at least 60 feet of open perimeter, can be unlimited in area as well. So those are our unlimited area provisions. I'm going to pick up the pace here a little bit to try and get us further along through the content here. Firewalls can be used to define separate buildings for allowable building size. And so section 706, specifically table 706.4, provides for firewalls, and these are separate and distinct from fire barriers and fire partitions and other types of assemblies that the code provides. But only type 5 construction can use combustible firewalls, meaning wood firewall can only be constructed in type 5 construction. All other types are going to require non-combustible firewalls with the fire resistance ratings as shown. Podium buildings, pretty common all over the country. They're covered in section 510 of the code. You've also probably heard the term pedestal building, stack building. These are buildings with a 3-hour fire resistance rated horizontal assembly between upper and lower buildings. The upper building can be groups B, M, R, S2 open and enclosed parking, and group A with an occupant load less than 300. And then the lower building can be any occupancy except group H, and that lower building will be type 1A construction. So those types of buildings are ubiquitous. We have provisions in 510.2 of the code that talk about how we determine the building height in feet, which is measured from the grade plane. So if you look on the left side of this image, we're measuring height in feet from the grade plane, whereas we can measure number of stories from the top of the podium or pedestal. So you could get a few more additional stories into that upper occupancy group with this approach. Now we'll talk a little bit about fire resistance. And table 601 is usually a pretty common starting point for determining fire resistance rating requirements for building elements. What we'll point out here in this slide, and the table deals with primary and secondary structural elements, but as the new types of type 4 construction were added to the code, 4A, 4B, and 4C, the committee responsible for getting this into the code decided to use the same fire resistance ratings for type 4A that are required for type 1A. So the blue oval boxes show you that those fire resistance ratings are identical for 4A and 1A. And then for type 4B, it was matched up with type 1B construction. And because type 4C doesn't have a comparable type 1C, the conservative assumption is that type 4C is also going to have the same fire resistance ratings as type 4B. And that's a distinction from type 4HT, which, the heavy timber approach approach to fire resistance is based on those minimum sizes that are deemed to comply with the code requirements as spelled out in this table. So in 703.2.2 of the code, there are different methods for determining fire resistance. We're going to look at two of those, prescriptive assemblies and a calculation approach. So most all of these approaches have a basis in ASTM E119 testing or the UL equivalent, UL 263. But for prescriptive assemblies, there's a whole section of the code that lays out different types of assemblies, not just wood, but all types of assemblies, both vertical and horizontal assemblies, that if built to the exact specifications laid out in those tables, have the fire resistance rating as shown. And for wood assemblies, AWC has a document called Design for Code Acceptance number 3 that provides the assembly ratings for both horizontal and vertical assemblies, and a lot of these have made their way into the code and match up identically with what's shown in this DCA3 document. So you can see the link, and that's a free download from AWC's website as well. The other method we mentioned is the calculated approach, and NDS Chapter 16 is referenced specifically in the code as the way to calculate fire resistance of exposed wood members, and now there's part of the approach that allows additional protection, non-combustible protection, to be additive to that calculated fire resistance rating for an exposed wood member. And so that's spelled out specifically in NDS Chapter 16. We mentioned wood and non-combustible construction a couple of times in Type 1 and 2 applications, which requires non-combustible materials. Section 603 of the code has 27 specific applications where combustible materials can be used. One of those is fire retardant treated wood, which is still considered a combustible product. But there are a lot of areas in that list of 27 where fire retardant treated wood can be used, and non-bearing partitions, non-bearing exterior walls, roof construction, balconies, porches, decks, exterior walls in type 3 and 4 all are examples of where FRT can be used. Heavy timber is also permitted in roof construction as an alternate to the 1 hour fire resistance rated non-combustible construction, and we talked about that earlier, and that shows up in footnote C of table 601. So building features really looks at interior finishes and some other items that we'll touch on here as we get a little closer to the end of our discussion. Interior finish is determined or characterized by these flame spread indices for Class A materials 0 to 25, Class B between 26 and 75, Class C up to 200. And this table in Chapter 8 of the Code, 803.13, shows where those classifications are required depending on the use group and whether the building is sprinklered or non-sprinklered. So here's another example of where sprinklers give you a benefit and would allow you to use some lower classification, lower classified finish ratings or flame spread ratings for some of these wood materials. And that's another one of the benefits that we talked about earlier. Now, if you're trying to figure out what the flame spread index is for a certain wood product, AWC has a publication here called Design for Code Acceptance number 1, and most wood species are going to qualify at least as Class C, some Class B. Most of your Class A products are going to have some sort of fire retardant treatment associated with them. But you can download this document, and that's kind of a compendium that they keep up to date with the flame spread ratings for different wood products. Now, also in Chapter 8 are some exceptions where wood can be used, and traditional wood floor coverings, like a hardwood floor, for example, in a building, are exempt from those finish ratings, as are mass timber elements. So any type 4 structural elements, except for exits, egress areas, are exempt from those interior finish, and the flame spread is a big part of that. So those exemptions exist for all type 4 construction. When we start talking about cornices, eaves, overhangs, exterior balconies, and other types of projections, then the code is going to have some limits on distances of those projections to the lot line. 2 feet is pretty much the minimum, and once you get up to or exceed 5 feet, then a lot of those restrictions go away. So there's a table in the code, and this kind of summarized here graphically what some of those limitations are going to be for wood projections. We've also got definitions in the code for what are called naturally durable wood species. And so you see that definition here for heartwood of redwood, cedar, black locust, black walnut, that can be used in certain locations subject to decay. If you're not specifying one of those naturally durable species, then some sort of preservative treated waterborne preservative would be needed. All right, now we're into Chapter 23, some of our structural provisions. Chapter 23 is going to list minimum standards for quality and design considerations, general construction requirements, conventional light frame construction. There are 5 different compliance paths You'll see allowable stress design, or ASD, load and resistance factor design, or LRFD, conventional light frame construction in section 2308 of the code, the wood frame construction manual specifically referenced in section 2309 of the code, and there's an ICC standard 400 for log structures. So this list in 2303 is really sort of a summary of the various subsections in 2303 for the different wood products and a code path for those wood products and their connections. And most of these are going to reference some sort of manufacturing or design standard. And so that's a code path that's pretty important for all of these wood products that you'd specify. Also in chapter 23 is a description of where performance versus prescriptive requirements apply. And so you'll see an overview in section 2304 that will give you a path for the conventional light frame construction provisions in section 2308. And outside of those prescriptive limits, then design or engineering would be required. Here's a table dealing with exterior wall sheathing in 2304.6 and different products, wood structural panel products. If they have a certain panel nail spacing, you see the different wind speeds and exposure categories. These wind pressures are going to be based on your component and cladding wind loads or wind pressures per ASCE 7. And so an example here of where these products can be used prescriptively in the code. Lumber decking up until the 2018 code prescriptively required 20 penny common nails to fasten lumber decking. And with newer power-driven fasteners available in the market and the resurgence of nail laminated timber that's available now and used in mass timber construction, this table was added to allow for those smaller diameter fasteners than the 20D commons that you see. There is a prescriptive table, 2304.10.2, that lists various fastener requirements for, this is kind of a catch-all table for roof systems, wall systems, floor systems. And one of the things that happened with the development of ASCE 716 was an increase to component and cladding pressures that drove the nail fastener spacing requirements for roofs to 6 and 6 rather than 6 and 12, and even tighter for small diameter fasteners, like you'd see in some of the power-driven fastener equipment. And so take a close look at this table and the limits on nail spacing, the prescriptive nailing requirements in the roof. This is an often overlooked table, or at least the revisions that have been made are often overlooked in some pretty low wind speeds and exposure categories. For example, 110 mile per hour exposure C would need 4 and 4 nail spacing rather than 6 and 6. So just an important consideration that you need to look at. For lateral force resisting systems, we're going to reference the wind and seismic standard, special design provisions for wind and seismic for shear walls, diaphragms. The stapled shear walls and diaphragms actually are still contained in the IBC, and so you'd go to the IBC for that type of information. For allowable stress design and load and resistance factor design, the NDS and the wind and seismic standard are dual format standards. So you're going to get both allowable stress design and LRFD in these two reference standards. When we get to 2308, this is our conventional light frame construction provisions. This table gives you a comparison of IRC or International Residential Code versus IBC 2308 conventional construction provisions and 2309, which references the wood frame construction manual. And so this might give you a better sense of the limitations and the application for these specific codes and standards. And so won't spend a lot of time going through those here. Again, hopefully you've got these handouts that you can take a look at to help you determine where your building might fall within one of these three categories, or what options you might have available, for example, with the wood frame construction manual that you may not have realized existed. The wood frame construction manual can be used for non-IRC buildings, for risk category 1 and 2 buildings only, and it's typically going to be a single story application, but for some common commercial retail buildings like restaurants and office buildings, you can determine your lateral design for wind and seismic, your gravity load path, using this wood frame construction manual. All right, so let's talk about precautions during construction. This is from chapter 33 of the code. And here we're looking at standpipes, water supply, non-combustible protection, exterior wall coverings, and the owner's responsibility during the construction process to provide construction fire safety. And this shows up in both the fire code and the building code. And this is for that vulnerable time when a building is being built and there are no active sprinklers yet, and in some cases the passive fire protection from non-combustible products like gypsum has not been added. And so one of the things you'll see, and this applies beyond wood construction, but anytime combustibles are on the job site, the fire code in chapter 33 is going to require a daily fire safety inspection. And that's looking at hot work areas, temporary heating equipment, debris and trash removal, temporary wiring, flammable and hazardous materials. The example shown here on the slide is making sure the fire hydrants are unobstructed and clearly visible. And there's a whole checklist of items that are going to be required for this daily fire safety inspection. And I think we're getting close to the end here. We're going to talk a little bit about energy and acoustical and then turn it over to Ed. So chapter 13 of the building code requires or provides several different compliance paths for your energy design. One's the ASHRAE 90.1 standard. Another is the prescriptive design provisions for commercial buildings. The other is performance design. All of these per the International Energy Conservation Code. And the advantage that mass timber and log structures have in this process is that those can be designed as mass elements, which gives you an advantage with your U-factor approach in energy calculations. And then for acoustics, we're looking at chapter 12. STC ratings and IIC ratings are spelled out there, especially for multifamily buildings or student housing, dormitories, that type of thing. In DCA 3, which we talked about earlier, which is a compendium of fire resistance rated assemblies, there are also the STC and IIC ratings for those assemblies if those have been tested and are available. AWC has also developed a technical report 15 for calculation of sound transmission parameters for wood frame assemblies and an accompanying calculator. All of these are free documents that can be downloaded from the AWC website. So I'm going to end there and turn it over to Ed, and he's going to talk you and walk you through the heights and areas calculator that's been jointly developed by AWC and ICC. Ed?
My name's Ed Lisinski, and I'm the Midwest Regional Manager for the American Wood Council. To wrap us up today, I will present a virtual tour of the newly updated height and area calculator that you can find on our website. The calculator was just updated for the 2021 IBC in correlation with the 2021 Code Conforming Wood Design Guide that Buddy just covered. So we'll start on the website here, which is awc.org. Hopefully everybody knows that. And there's actually three options of how to get to our calculators. If you look right along the top of the screen here, there's several options of our store where you can buy our standard sustainability information, our standards themselves, calculators, webinars and e-courses, and then a search button. Well, of course, if you click on calculators, it will take you right to our calculators. The second option, right here on the center of our home page, is a button that will take you to calculators and tools. So same thing, it'll click you right to it. Let me back up again. The third option, a little bit more difficult to find, but you may find yourself in our resource hub. And so I want to show you what's there. So if you click on resource hub, you'll see that the second option is also calculators and tools. So when I click on calculators and tools and I get to our calculators page, you'll notice that there's actually 6 calculators that we have out there. We have a calculator that is for span options for wood joists and rafters, one for connections, one for height and areas that we'll talk quite a bit about here today, an acoustic calculator, an energy calculator, and then the WoodWorks software for wood design. That's a full wood design suite. The full design suite one is actually one that you have to pay for. The other 5 are free. Anybody can use those. And actually a couple of them can even be downloaded as an app on your phone. But we won't talk about these other ones. You can explore those on your own time. We will get into the height and area calculator itself though. So the height and area calculator, when you click on that, a little bit of information up top. Basically just telling you, though, that this is a joint effort between the American Wood Council, WoodWorks, and the International Code Council. So I do want to thank WoodWorks and ICC for their help on developing this calculator with us. Just to give you a brief overview, you'll see some basic information here that you'll type in about your project itself. You'll type in the frontage on the wall sizes. You can reset and clear everything out. You can hit calculate once you're ready. There is a question mark here that will provide you some information about the calculator itself. And as you scroll down here towards the bottom, some information on the 2021 Code Conforming Wood Design Guide that Buddy just covered. You can also go into full screen mode, and I will do that right now just to show you what that looks like. So here is the calculator in full screen mode, a little bit easier to see, and you don't have to scroll as much. As you go through the side here, you'll see a whole bunch of question marks. Anytime that you see one of these, if you click on them, it will give you some information. So let me click on the sprinkler system one just to show you what that looks like. A little text box will pop up. If you select none, you will see, the building does not have any sprinklers. NFPA 13 is meeting IBC 903311. NFPA 13R meets 903312, and so on. So you can click on that question mark again and get rid of that text box. You may just, as I clicked on that, you'll say, yeah, NFPA 13 showed up in the question mark, but I don't see it here as an option. Well, I'll get into that in just a second as to how that option shows up. So starting off at the top of the calculator here, we have the basic program, and then we have an advanced program. I'm going to walk through the basic program for you, but then I'll also show you some of the stuff in the advanced, but I won't actually work a problem through the advanced option. You can type in your project name if you're interested. We'll call this one Lisinski Towers. Name it after myself. You can select the building code version that you're on of the IBC, and you'll notice that we have it from the 2021 IBC down to the 2006 IBC, and we also have the 2019 California Building Code as an option in here as well. The sprinkler systems, like we talked about, you have none. You have NFPA 13 right now. You can also get 13R on there as well. So that's sort of the basic information. What I'm actually going to go through is this example that Buddy showed earlier in the presentation when he talked about area increases for frontage and a few other things. You may recall these couple slides, and we'll see. This was a 4C type B building, occupancy building. So we're going to go through using the calculator and kind of check Buddy's math on them. All right, so the building height, that's sort of your first input on the actual project itself, right? When I click on the height here, you'll notice that a text box or a calculator box pops up. Now you can type this in directly, so maybe it's 45 feet, 8 inches, and you can hit done, and that works. I can also type it in on my keyboard, so I'm just going to type in 44 feet and leave it at that. I can also, I should mention, you'll see my cursor's off. I can type in 47 feet, 2 inches, and that's also going to enter that in. So couple different ways of entering your information. Stories above grade plane. We'll say this is a 4-story building. Here's where you can select the occupancy. And you'll notice when I click on that, a text box pops up here of all the different occupancy types. The example that Buddy went through was a B occupancy, but let me just click on R2 just to show you that when I select that as an occupancy type, you'll notice now up above here that NFPA 13R does pop up as an option for you, right? If I click on R3 occupancy, now NFPA 13D also shows up as an option for you. But again, we want to go with a business occupancy, and it is sprinklered. The floor area that we went through on that example, 125,000 square feet, and I just typed that in on my keyboard. You'll notice the next question down is whether or not you want to permit interpolation for the increase factor in the increase factor table. Again, if you click on that question mark, and I know Buddy went over this a little bit, but footnote A does permit interpolation. However, certain jurisdictions may not permit this. I know that there are some jurisdictions, some states out there who have adopted the 21 code and have actually taken out that interpolation button. So we've given you an easy toggle here to put that on or off if you want to interpolate or not. So we'll just leave it off for now because that's how Buddy went through his example. Now in that example, I'll bring that back over here real quick for you. You'll see again 125,000 square foot building. We've got 250 feet by 500 feet on the sides. We've got a 28 foot, a 100 foot, a 30 foot, and a 15 foot fire separation distance on the 4 sides. And I believe this side on the right, this side on the top, and the side on the left all had what would be considered fire department access to those. So let me slide that back out of the way. In the basic option, you're just permitted the 4 walls. So this is for basic buildings, again, 1 occupancy throughout the entire building. But we'll start to type in that information. So again, we have access, a clearance of 28 feet. And again, I'm just typing this in on my keyboard, but you can certainly do it on the screen as well. The length of that wall was 500 feet. Wall number 2 in the back had a clearance of 100 feet. And that building length was 250 feet. Wall 3 had a length of a clearance of 30 feet and another length of 500 feet. And wall 4 did not have access to it. It had a clearance of 15 feet and then again a length of 250 feet. So again, once you get through with this, you can hit reset. It's going to wipe everything out, or you can hit calculate. Hopefully you're going to hit calculate. The top of this calculator is going to give you all the information that you typed in, right? So again, we're in a basic analysis mode. You've got the project name, the code that you're in, the sprinklers, your building height, your number of stories, your occupancy, your floor area, and then each of those different frontages. Now down here, it's going to give you that frontage increase that you'll see down here. And one other cool thing about this, if you click on that button, or if you click on that 0.63, it's going to give you how it came up with that information. It's going to give you the calculations on how that was all determined. So all that information is provided in there. Click on it again, and that text box goes away. I'll come over here to Buddy's slide again, and you'll notice that he came up with an increase factor of 0.63 as well. And so that's what we have. Now, if you scroll down here towards the bottom, it's going to give you your construction types that you can build with and meet each of these, meet that building size and height. So you'll see what options we have here is type 1A construction, 1B, 4A, and 4B. Now, Buddy was trying to get to 4C construction. And so much like in his example, that was not permitted. I'll also mention here under the floor area height limit, if you click on that, again, it gives you the calculations and how that number was derived based off the calculations in the code. So this did not make it for type 4C. You can actually hit the done button here, and it's going to take you right back to those same inputs that you had earlier. So now if we wanted to try to change this to 120,000 square feet and shrink these sides down to 240 and 240, we can recalculate that. And if we scroll down now, we see that 4C construction is permitted, and that weighted occupancy of 120 square feet per floor is about 73% of the 163,000 square feet that would be permitted. So with that frontage increase and everything else added in. So if we shrink that down a little bit, we can get to a 4C construction. I'll also let's see what happens if we allow interpolation. Let me just hit that calculate button again. And now you'll see that the frontage increase actually goes up to 0.7020. And again, if you click on that, it's going to give you all the math on how that number was derived. And now you'll see that the 4C construction actually went up to 166,590 square feet. So a little bit more on that frontage increase. All right, let me back out of this. And just briefly, I want to show you the advanced option as well. So if I click on advanced, it's going to wipe out everything from basic. If you go back over there, it is still there though. So if you can kind of do these simultaneously. But in the advanced, again, you've got something similar here where you can do the code option up here at the top. It then lets you select the type of construction that you have. So again, we want to do this as a 4C. Sprinklers are in there again. Our height and stories translated over from that previous one. Here we can talk about separated occupancies if you wish. So maybe we have more than one occupancy per floor. You can also select if you're Section 507 compliant, with the exception of the 60-foot yardage, and that gets into some of those unlimited area options that you may have. And then again, the increase factor interpolation. Now again, we've got 4 stories on here. Just kind of clicking on that again. You'll notice down here then the inputs for the walls and the floors are quite different. So here we have advanced frontage, so we can tap on that and add a frontage segment. So you can add as many walls as you want here. If you have a building with 15 exterior walls, maybe it's a weird shape, and each one of those walls has different frontage to the or different fire separation distance, you can type that all in. Let me just go through a little bit on Buddy's example before, though, just so we can have this. So we've got length of 500 feet. It will talk about the clearance that you have at the start over here, and then clearance that you have at the end. So at the start, we had 28 feet, and at the back, we had 28 feet. So we'll leave that wall just exactly as it was in that example. But let's add another segment here. We've got 250-foot length. We had access in the front of 100 feet, but maybe by the time that we get towards the back, yes, we still have access, but maybe that's cut down to 27 feet because maybe that property line runs at an angle in the back. We can then add in the next segment, which was another 500 foot. That had access, we'll say that starts off at 25 feet, but by the back of it, maybe we're down to 5 feet and no access. And then the fourth wall, we'll say that one is only 100 feet with no access of, we'll say it's got 5 feet at the front, and it runs at an angle, so we'll say it's got 0 on the back. And maybe that wall actually has a little jog in it. So now we also have another 150-foot section that is at the property line, right? We have 0 clearance on that from the start to the back. And again, you could add as many wall sections as you like. And again, it's really just counting the walls that are perpendicular to the property lines or the another building on the same lot or the road or public way. So again, looking at that fire separation distance on those. We can then go into the different floors and add different occupancies. So maybe floor number 1 is a B, and that's that 125,000 square feet on that first floor area. But on floor number 2, now maybe that is multifamily up above. And that takes up 100,000 square feet, and that there's also a let's say a performing arts center there that takes up 25,000 square feet. And you can see how you can start to really build this out on each of the different floors. Let me just I'll put something in here. I'm just going to make up some numbers here. So we'll put in business up here. Also at 125,000 square feet. And then floor number 4 here, let's throw in low hazard storage up top at 125,000. Oops, 125,000 square feet. All right, and just hit calculate on that just to show you guys what this kind of looks like in the advanced. Now it's going to tell you that construction types 1A, 1B, 4A, and 4B may be viable for the current options here. It's also going to pop up that there's some errors here, and I didn't try this out, so that's not surprising, I guess, to me. But I just wanted to show you again. The frontage increase is still in here, still gives you all that information. You'll see things that are in red, and that's going to give you the errors. So if you click on that, you can see that. What did I have in there? You're only allowed 87,170 square feet for whichever occupancy I put on that first floor. Oh, the R2. After you put in the averages, weighted averages, and everything. So we had I put in 100,000 square feet. I'm only permitted to have 87,000 square feet. So I'm 14% over what I'm permitted on that floor. So I just wanted to kind of break it just to show you what that looks like if you do put something in there that's wrong. And again, you can kind of see a few other red marks in there. And again, each one of those, you can click on those. You'll see some of them are flashing here. Again, you can click on that flashing red exclamation point and see that this is over the 87,000 square foot area limit for R2 residential. And some of these are in blue. You'll notice some blue exclamation points. those are just warnings saying that the on this particular floor, floor 2, the B occupancy area is not over the area limit because the building has sprinklers in it. So kind of gives you a few warnings. And again, if you see something flashing in red, that means you can't build your building that way. Something is wrong. So again, a lot more options here in the advanced one. It does get a little bit more complicated on the summaries here at the end. But again, you can do multiple occupancies per floor. You can do separated occupancies, non-separated occupancies. You can do as many different walls as you'd like. And again, if you do run into something like that, you can hit the done button, and that's just going to take you back to the beginning here, and you can adjust some of your numbers and try to come up with something a little bit better. So that's the height and area calculator. Again, the basic version and the advanced version. And with that, I think that kind of wraps this up. Again, if you have any questions, feel free to reach out to the American Wood Council, and we can certainly help you out with this at any time. Thanks.